First, what is similarity, you might wonder? So remember, congruence was everything's the same. All the sides are the same, all the angles are the same. For similarity, all the angles are going to be the same, but the sides are going to be proportional. Okay, so in case you don't remember what proportional means, I'll draw you an example. You don't have to draw it. Let's say that I have these triangles, and one of them is like 5, 5, and 10. And this one's like 10, 10, and 20. These two triangles are proportional because if I put like the small side over small side, big side over big side, what fraction will it reduce to? 2. Yeah, well, it depends if you do this way. It doesn't matter that way or this way, right? 10 over 5 or 5 over 10 or 20 over 10. So this side over this side reduces to 2. This side over this side reduces to 2. So that's what it means to be proportional. It's that you can put the sides that are corresponding over each other in fractions, and it should reduce to the same thing. Okay, so that's proportional, but the angles are going to be the same. So we have 3 different ways of proving that triangles are similar to each other. And the first one is with angle-angle similarity. So this says that if 2 angles of one triangle are congruent to 2 other angles of the other triangle, then the triangles are similar. So this guy is angle similarity. And it's if 2 angles of one triangle are congruent to 2 angles of another triangle, then the triangles are similar. All right, so I'll do the first one with you and then let you guys try the other ones. So for this one, we have 2 different sets of congruent angles in our triangles. So that's all we need to say that yes, these 2 triangles are similar by the angle-angle similarity theorem. This little squiggle means similar. So just like we had a congruent symbol, the squiggle means similar. And then we'll just write our similarity statement. We'll say triangle MNB is similar to triangle QVW. And I'll let you guys try 2 and 3 with your group. All right, do you just want to roll a chair and like take a whiteboard in the hallway so you can take my space? Or does that work? Okay. No. Wait. You can just take this chair. Yeah, the special chair. Okay, did you guys share with your group what you got? What did you guys get on number 2? You got no, that's good. What did you guys get on number 3? Yes, by the way, on number 3, as review, these angles are congruent because of why? Because they're vertical angles. And then these guys, right angles, and we know all right angles are congruent. Okay? Awesome. All right, so the next way that we can prove that triangles are similar is called side angle side similarity. Okay, yeah, we'll fill that in first. So side angle side similarity. So, in 2 triangles, if a pair of corresponding angles is congruent, so you have one congruent angle in each triangle, and the sides including the angle, so the sides that are like attached to the angle, are proportional, then the triangles are similar. Okay, so for example, on number 4, we have a congruent angle, that 120-degree angle in each triangle. And so now we're just going to set up proportions, make sure that they reduce the same fraction. So we'll set up small side over small side and then bigger side over bigger side. So we'll do 4 over 6. And that should reduce to the same thing as 6 over 9. And do they? Yes, both of these fractions reduce to 2/3. So therefore, the sides that are surrounding the angle are proportional, which is why this becomes side angle side similarity. So these guys are, yes, they're similar by side angle side similarity. And then we can write our similarity statement and say triangle MNL is similar to triangle PRQ. Okay, let's see. We can go ahead and do number 5 real quick together too. So if we do number 5, we have a congruent angle already marked. I'm going to put the corresponding sides together. I like to do small over small, bigger over bigger. So I'll do 6 over 8. That should reduce to the same thing as 9 over 12. And both of these guys will reduce to 3/4. So since the sides that are including the angle are proportional, yes, these are similar by side angle side similarity. And we can say that triangle NLM is similar to triangle UTS. Questions or concerns so far? All right, okay, on to the last one then. The last way of proving that triangles are similar is called side-side-side similarity. So side, side, side similarity. And this one says, if all 3 pairs of corresponding sides of 2 triangles are proportional, then the 2 triangles are similar. So for these, we're going to set up 3 proportions and then make sure that all 3 of them reduce to the same fraction. So on number 6, I like to do small over small, medium over medium, large over large. By the way, that helps me because sometimes your triangles will be rotated or maybe reflected, and it may not always be left side over left side, bottom side over bottom side. So instead think like small over small side. So 3 is over 9 because they're the 2 smaller sides. So 3 over 9. 4 goes over 12 because they're the 2 medium sides. And 5 goes over 15 because they're the 2 largest sides. And then they all reduce to the same thing. They reduce to 1/3, which means that yes, these guys are all proportional, so they are similar triangles. So triangle STU is similar to triangle XWV. So you guys try number 7 when you're ready, and then we'll check it. your group. What you got in number 7? So spoiler, this one's a yes. So if you got no, double check your orientation. Make sure you put small side over small side, medium over medium, large over large. Yeah, because this one's tricky, right? Because this triangle on the right, it's like been reflected, yeah? Which means that the side on the left actually corresponds to the side on the right for the second triangle. But if you're doing the smallest side over smallest side, measurement-wise, medium measurement over medium measurement, big over big, then you'll have the proportions in the right spots and say that they all reduce to 1/3, so this one actually is a yes. Okay. Okay, questions so far on this one. How did you guys write the similarity statement on this one? Anybody want to share? Since it's reflected, it's kind of maybe a bit trickier. Okay, let's see. If we had the first triangle do R, Q, P. I'll tell you guys how I kind of think about it if you're kind of stuck like on the visual part. So for me, I think, well, R, that angle is in between the smallest side and the biggest side of my triangle. So the angle on the right side that's between the smallest side and the biggest side of my triangle is O. So that's how I know that R and O go together. And then Q is next. Q was in between the smallest and the medium size, the 7 and the 10. So N is the one that's in between the smallest and the medium measurement of the other triangle. So N goes next, which means M is last. Okay, I'll let you guys work with your groups to do the next 3, and some of them are tricky, so maybe work together, share thoughts, and then we'll check them in a little bit. If you're stuck looking at that first one, the smaller triangle is like nested inside of the bigger triangle. That helps you. Okay, so the small triangle is this one right here. The bigger triangle is this one right here. And if we have measurements, let's just check. Zach, so how big is this triangle? Do you want to try it now or do you want to try it? Okay. which side is the median of this triangle? 10, so it's going to divide over 10.
So where's the variation now? And then 6 right here. So I'm like wondering, we have 6 plus 6 and this entire side of SE.
Correct. Yes. Okay, the person with the shortest hair at your table, share what you got for the first one with your group.
Yes. Wait, what was the question? The first one I got yes. So I got yes. Yes, yes, and no. Is it yes? So how would you
Parallel doesn't mean they're
then you have that angle since they both share that. Wait, so you got yes for SAS? So if you set up this, would it be
Okay, we can run through these together real quick. I love how you guys were explaining things to each other in your group. That's super awesome. This first one is kind of tricky. So for your two sides, the smallest side of the small triangle is 6. The smallest side of the big triangle is 9, so 6 over 9. And then on the other side, 10 over 15. So 10 over 15. So both of those guys simplify to 2/3. So that means that your sides are proportional. But where does the angle come from? Like, where's a congruent angle? The top. Who remembers what property that's called? Reflexive property, yeah. Because this angle L belongs to the small triangle and to the big triangle. And whenever you have an angle overlap itself like that, angle L has to be the same measurement for both triangles, right? Which means it's congruent to itself. So just FYI, we're using the reflexive property there, which means we have two proportional sides and an angle in between. So this guy is yes, similar by the side angle side similarity theorem. By the way, I'm doing the squiggle after I write SAS to show that I'm not using the congruent side angle side because we had, congruency for side angle side. I'm using the similarity. So add your little squiggle after side angle side. If you don't have it already. So we say side angle side similarity. So then for your congruency statement, you could do something like triangle KLM is similar to triangle JLN. Something like that. For the second one, these colored in triangles mean parallel. And remember, just because something's parallel doesn't mean it's congruent. That was a great question I got. Because for example, I can draw you these two lines. They're parallel, but are they congruent? No, right? So parallel and for these are going to mean, let's look for angles, like alternate interior and corresponding are the most common. So if I highlight my parallel lines, pick a transversal, I have one set of alternate interior angles there. And then if I switch parallel lines, use the same transversal, I have a second set of alternate interior angles. So that's where the two congruent angles in each triangle comes from. So yes, these guys are similar by the angle-angle similarity. And you could say triangle TRS is similar to triangle, let's see, SQT.
Miss Taylor?
Yes.
Don't the arrow marks represent they're both congruent?
Good question. Parallel. So you're thinking of the little dashes. If we have little dashes, then that would mean congruent. The colored in arrows mean parallel.
Okay.
Good question. Other questions? Okay, last one then. So for this one, we had lots of measurements. By the way, if this is like on a test or something, I'd want you to show me the proportions that you set up. So you'd have had 3 over 6, 5 over 10, and 6 over 12, which since they all simplify to 1/2, yes, these guys are similar by side, 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 similarity. Okay. On a scale of 1 to 5, how are you guys doing today so far? Totally don't expect perfection because we just started. Okay. All right. So let's, on the back side, we'll do this one and then we'll take a brain break. So this one we're going to do solving style. So go ahead and read this one with your group and try and just answer number 11. See if you guys can figure number 11 out with your group. Ready? Talk to each other. Go.
Okay, based on the person's height, just forming another triangle right there. Yeah, from like B to from B to C. Yeah, B to C. Yeah, exactly.
What do you guys think for number 11? Anybody have any ideas of the 3 theorems? Which one you would use to say that these 2 triangles are similar? So definitely we have an angle in there, right? What angle in there might be congruent? Angle A works, right? Because angle A is that reflexive property again, because it's overlapping. Because if you think about it, the sun has to make the same angle with the person as it does the flagpole, too, just logically. Are there any other angles in there that have to also be the same? 90 degrees, right? The flagpole is perpendicular to the ground, and so is the person. So actually, that's where our second one comes from. We can't use sides yet on this one because we don't have enough measurements to check proportions and see that they work out. So for this one, we know that they're similar by angle-angle similarity. And now that we know they're similar by angle-angle similarity, we can use proportions to solve for missing pieces. So if we're solving for the height of the flagpole, I'm going to do small side of the man's triangle over small side of the flagpole's triangle. So that would be 5 over h. So small side of the man's triangle over the small side of the flagpole's triangle, which is the one we're looking for. And we know that should be equal to the proportion for the other side set. So the bottom of the man's triangle is 6. What's the bottom of the flagpole's triangle? 18. Yeah, you got to make sure and do the 12 plus 6 to get that whole bottom of the triangle in there. And then we can just cross multiply. So we get 6h equals 90. Divide by 6 on both sides. H is 15 feet.